So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 225, and in this video we continue with our flowchart. And in our last video we already created a flowchart, the first part for the sort linked list algorithm here, function here. And it was the part where we covered the first part here till the while loop here. Till this while loop we covered it. Let me show this fast again. And this is the part on the left side here. We created here this little part, and then I created here on the bottom a replace diagram, which means all this part here I can just show like this one because it's related to this one, and we can examine this later. And on the right side I already created another flowchart, and this is the second part. And the second part is this while loop, but this while loop is very big, not a normal while loop. And you can see this while loop is too big actually to draw a full flowchart. So I split this while loop as well in different parts. And you can see we have here a part 1, which goes from here to here. This is just some condition checks. Then we have another part, which is this one here, which is till here, I think, which is end condition for loop. And then we have another part, which will be here and very bad commented, but I will comment this later, is the second part, the last part in the while loop, which is the normal swap. All right, and in this video, I want to cover the first part of the while loop, which is this one here, because like I said, it's again too big. And our flowchart, we need only a flowchart to understand the code. Again, you can just read here the code and try to understand it. And let's do it and see if we can understand this code, what I wrote here. And I will say you right now, you will get irritated a little bit, because when we just watch the keyword, just watching the keywords, it looks so easy. We have a if, and then we have a throw, and then we have a else if, and then we have a if, and then we have a break, and then a else if, break. So you can see that's it. That's the whole thing about this first part. So the keywords and the things what I use are so simple that should be not a problem to understand. The keywords we understand, very easy keywords. But now comes the problem. What is the meaning of this keyword? Let's see if you understand this one as fast as you understand the keywords. Do you understand this throw here? Yes, we know throw is an exception, right? That's still okay. But do you understand this break here without reading the comments, of course? Let's try, don't read this comment here, because I used this already to indicate it. But without reading the comment, this break here says only, okay, this condition is true, then I will break. Break means most time, just go out of the while loop or go out here, and we are in a while loop. That's kind of stuff you understand, right? And the same thing goes here. Else if this condition is true, then you say break. But that's the problem. This is just keyword understanding. This is not program understanding. And the program understanding, I already created here a diagram. This is the second one. Let's see if we understand this here a little bit better, because I already created. And let's go here fast through. I don't create it from scratch. I just use it this time, because last time I created this one. So this time I created it beforehand and we use it. So it says here, let's see, I want examine, for example, this P5. No, it says here P85. Position is an error. Okay, that makes sense, because this P85 says here. And again, when we read a flowchart, we read the comments. Very important, because this is the keyword. We know this is okay, but the comments are very important. It says here pointer not set at this point. Now this keyword makes sense. Okay, it gives an error because the pointer is not set. It must be set, at least in my definition. Here a very tricky part, by the way, for starters. What is the tricky part about this if statement here? When you read it, this if statement must be true, then I throw an arrow, which let's go here to the if statement. You can see the if statement is here P8. Again, if means all-timer condition, true and false. And the difficult part for starters, because it's not so intuitive, is I use here the negation to be true. So with other words, I use here a value. It is called the swap pointer first position. And then you can see here is an ampersand, which means I negate this. And this negation must be true here. And the second pointer, again, and with an ampersand here in front, I negate it must be true. So both must be true, are negated. So with other words, both must be false, then both get negated, becomes true, then this AND becomes true, and then you can enter this true body, and this true body is throwing a error. So this little part here, it's a little bit complicated when you read it, but after you get used to it, it's not so complicated. But just for starters, most time, hard to understand this negation here and then going in and then throw an arrow. But this is the semantic. Okay, we understand this. We just throw an arrow, but the best part here is just the comment. It says here, pointer not set at this point. With other words, the whole code here is just checking if the pointers, these two pointers, are set or not, and it will, if they are not set, it will throw an error. That's that. All right. Like I said, let's see if we understand the other breaks here, because like before, the break code understanding. So keyword break understanding is very easy. You go out of the loop. All right, that's okay. But let's see what happens here. P11. I jumped here to P11, and here is my break, and it says here, wrong. No error message here. Better use throw with catch. And actually, there is another problem here. It says here, break not handled. I wrote here a comment. This here is a comment, break not handled. This arrow here, by the way, is also a comment, because this is an endpoint with an arrow here. Here, arrow means just the whole the whole program actually will stop with an arrow, because that's why you throw an arrow. Or it is, or depends on the arrow, by the way. If you catch it differently, there it still can continue. But yeah, we talked about this a little bit with the try catch block. But here it says in P11, this break here, it says break not handled. We have here another arrow. So we can see, we enter here this if, and I say here, okay, the swap pointer first position, and should be, if this is null pointer, then this program should break. But what is the meaning of that? Do you understand it just by reading this? Of course not. When you read the code, probably not. When you read the comment, probably yes, because that's why the comment is here. It says here, if swap pointer first position, this is this one, is null pointer, this is just describing this is bad, but now comes the important part, then there is no list. Okay, if this is true, then there is no list. And then if there is no list, then we make a break. So now it makes a little bit more sense, right? Now we understand what this break is really doing here. And now try to understand this comment. It says here wrong. No error message here. Better use throw with catch, and that was just different thoughts here. Actually, you can use here a break, you can use here a throw, and then you have to choose which you want to use. If you use a break, what happens here? Break would exit the while loop. We know this. The break keyword goes back to the while loop. The while loop is finished, and it will continue with the code. We know this, right? We learned this. But the problem here is you have just no error message. So the user don't know what happens here. That's why I said here no error message here, because the user should at least know that there is something wrong. So first, that's why it is not handled. And then I said better use throw. That's not really true because you don't have to use a throw here because the break is all right in this position. Because you can just give the user information that there was a null PTR. And what you have to do here is normally give an option to go back to the user interface where the user can choose how he want to go on with the program. What I mean with that, the break happens here, right? Then it goes out of the loop and the user can enter an, for example, can load a new list because it says here there is no list. So we give the user at this point the option to create a list or load a list or anything like that. So you can see this little part here is actually a very big part, but I skipped this part here because we are here in the sort list function and not creating options for the user input. But this part is actually a very big part, and this throw is not so good actually because, like I said, this is not true. Let's say you can use you can use throw, but not so good. And the reason why throw is not good, because normally you throw something when you have an error, right? Throw means all-time error. Error means normally there is a special catch case, and normally when you read throw, the program should stop because it can cause big problems. Like here, I don't know if this is also a good solution. Pointer not set at this point. Here at this point, even a break at this point would be better. Just go back to a position where the user can have options to load a list so that all the setup can be updated and set. But in my case, I just wanted to show you the throw keyword and how to make a try catch block. That was just for exercise purposes. In real, this is bad. So when you read a throw in programming, it will start to try to stop the program and then try to handle this in the catch blocks. But instead, break is normally good, but break, you have to handle it. This one, what I made here, is just a break without handling it. That's why here, break not handled, bad. Let's see this one here. Here in my flowchart, I see, okay, the position here, endpoint break handled later. Let's see if we check the other break. So you read here the code again. Again, try to read it without comment. Just break and try to understand this. Do you understand what happens here? Without comments. Read it without comment. Try without, not read the comment. Let's hide the comment here. So this is the real code here. And if you read something like that, okay, it says here else if swap pointer second position is equal to null pointer, which means break. All right, which means the second pointer has no assignment. Okay, so far I can see it. And then I say just go out of this loop. That's all what I can see here without comments. Let's see what the comments can tell us. It says here, the comment says here, if one node, first of all, we get here new information. If one node, then it breaks. So at this position, I know this here, at this point, I have one node. So with other words, a special case in our list. The list has already one load and it's automatically sorted. So I don't know if you can understand this without a diagram. Let me show you this one also fast. Sorry. And here at this point, yeah, this is the special case with one node here. Oops, with one node, this one here. You can see here we have only one node. This the first one is set. And that's why, let's go back to the code. That's why swap pointer second position, null PTR. This is again, this, oops, not this one. Where is it? Here. This one, the first position, is this? Second position is null PTR, yes. So the second position is this one here, is null PTR. But the first one is set because we covered already the case before. And you can see then we have only one node, and now we read a little bit more. This break here P13. Let's go to our flowchart. P13 break handled later. Again, very hard to understand here. Special case with one node automatically sorted, so which means we know at this point we have only one node with this check here. And with this break, we know this one we don't need to sort because there is only one node and one node is automatically sorted. But important now, this one node must be realized that there is one node later and this one node must be printed out. So the following code must handle this case, the special case with this one node. And we have different special cases. We have here no list case, one node case. Then we have two node case, the normal sort list where we have more. You can see that we have think about the cases, and cases are called in programming states. So which state a program can be in. In this case, here at this point, we have the state where you have one node, right? We have to talk about states too, but right now I show you just here the flowchart, and you can see this little flowchart here, like before. This program looked so easy. So you can see this is the thing what we just discussed. And like I said at the start, here we have just if, throw, else if break, else if break. These are the keywords, and the keywords are so easy to understand. But the meaning is really difficult. You can see the semantics or the meaning, what this breaks do or the throws do or the ifs and all this kind of stuff is doing is not easy to understand. And that's why this flowchart can help. And here I indicate, okay, at this point you have to work, break not handled, you have checked this point. Okay, all the other parts you can see this is just normal flow. Okay, here's a if. It goes this way, it's okay, normal flow. Interesting is also this part here. We have to talk about this in a moment. But you can see this part you have to check separately. This part you have to understand separately. It's not easy to understand. And that is what I wanted to show you. Sometimes the code looks very simple. That was the first time when you read this little part here, this if, else, if. It looks super, super easy. And we know everybody knows what a break is doing. It is just going out of the while loop. But the breaks have here different meanings, and that makes it so hard. Depends where you use it. And that's why this kind of stuff can help. And important, very important, of course, the comments. The comments are really telling you why you are using this here, why you are using this, or what it is doing here. So you see the comments become more and more important to explain your code to other people, because if you write your own code, you probably know it, but after 2-3 weeks, I don't know if you know your code then too. If you have just here a break without a comment, in my case, I would not know it. I have just to go all the checks again. I have to analyze all checks here. What is the break doing? Where I have handled this one and what is this doing? So with other words, I would again waste a lot of time just to analyze the whole code. So here is one more special case which I wanted to show you. That was this. What is that here? What is that here? And this part is actually, we can watch this very easy. P9 and P12. We check just these two positions. P9, let's go here. P9 is here. P9 is a else if. And the else if, it's the else statement of P8. So, okay, we see it. P8 else statement. We have this here is a else if statement. Else if means else is, this is the else statement, which comes from here, this part. This else comes from P8. But we start here a new if. It's called in C++ else if, but in real it is a else if. You can see it. We have a else, comes from P8. And then we start a new if actually. And this one is this representation here. All right. But in C++ we use here else if like so. Just remember this one. And then you can see here is a condition, that was that. And we are interested in this. The true part works fine. so we skip the true part. Let's see what happens in this if statement, the else part. The else part, how again we check this, you can see the true part is this body here. It's the first part all time from our if keyword. And when we watch the else part, you can see the else part is just continue the code normally, which means we will cover these other parts later. So, and what you have to do then is here, the else part is end of the block. But the question is, why is the P12 also here at the same end? Because you can see this end here is the same end. Exactly. And this is just a representation, by the way. You can represent this so or so, how you like it, to indicate that they are coming to the same point. Or you can even connect this one here. So for example, you can connect, some people are connecting this one and indicating they are going to the same point. But let's check this P12 here. We jump to P12 and you can see the P12 comes from here. It goes here in the path. And again, it's the else path. So P12 is here, the else path. Careful, this again, else comes from P10. We can see it, the P10. This is the else path. And here we create again our if path, and this is the P12 path. But again, C++ is using else if. This is the combination of a else if, but P12 is this here, this part here. And the else part, again, this one is the true part because the first part is all time the true part. We covered this one. And again, now it's important. Now it's important what happens in the else part. You can see the code continues. And important is here, if here would be another code, then you would go first to the other code here. So with other words, we could have here other code. And that's why I indicated it this way with a separate line. So you could, but we have here no other code. And after this part here, you can see it is at the same part of P9. Right? The P9, the same else. So we are just continue with the code. With other words, we are landing at this point here. Both P9 and P10 are at this line later because there is nothing. After this line here, this little block here, the compiler would jump to this part. Then he will check there is nothing. He will jump, the compiler will go here and go here to the next part. So it will just go here down. And that's why they have the same endpoint. Because I just covered here the first part. Right? Here is the first part. So the first part, the while. There is one more thing I have to talk this while. Where is the while? But in a moment. So this is just to indicate both land. The compiler will later here. From here or here. And again, you can, in many diagrams, they are connecting this part here. For example, they would make here, instead of making two parts, they are just connecting this one here. And you can see this one is connected, goes here. This one is connected, goes here. But actually, this representation here is a little bit more clear. Why is this a little bit more clear? Not really more clear, but indicates more the real flow. The reason for that is this is another path where a code can happen here between, right? It's possible. This is a possibility. And here, if there is another code, can also happen here between, because that would be here the part. Where was it? Let's see. That is P12. Let's go to P12. This would be here the part after this one. So you can see here there could be other code here too, and that's just for indication, but you can make this like you want. You can just connect this one and then you have this one. I made this so that there are two paths at the same endpoint, which is here at this point. We are jumping out of this first part is finished. We are continue here. Here is our endpoint. The other endpoints are not the same path. You can see this are special endpoints. This are break, this is a break, and this is an arrow. That's very important. And now there is one more thing which I have to talk, and this is, where is the while loop, by the way? Because I said I want to talk about the while loop. So while loop is P7, but we have no P7 here. I started with P8. And the reason for that is, like I said, the while loop is the whole loop which I want examined, but this here is just one little part of it, and I have 3 parts. You can see it starts with P8. The next part, I have not covered it so far, would start here with P14, I think. The next part will start with here P14, because the last part was here P13. We can see this was the last thing what I covered. And this is just an endpoint. This means here I'm at the endpoint. And then this while loop P7 will just collect later all the parts together. What I mean with that is, let me show you this here. Let's make here fast a new diagram. For example, later when I have all the parts, I have here again a start point. But important is now what I have here is not like diagrams like here. I just take these parts here, what I created, these little things here, right? So I would just copy this one here. For example, copy, paste. Then you have this one here. Then you have created this one. And here's the label. You have labeled them. Just copy this one. Copy, paste. Why not copy, paste? Again. We copy this and paste this one here. Oops, where is that gone? Okay, I have to scroll a little bit down. And then you copy this one here. And this here will be later my final while loop. And this one is also not right. I have to do one more step perhaps. This is just my start point. And then I have create one while loop perhaps. Where is that here? This is my P7, and then I just connect them. And I made again a wrong thing. Perhaps I should take this one here, because what is the wrong thing here is this part here will be my true part. You can see we have a while loop. Where's P7? Come on. Here is my while loop. And a while loop is again a conditional. The condition goes only in this while loop. Here the whole thing, what I have, is true, and else is just continue with the code. With other words, I will just later when I'm finished will connect this so and so. Something like that. And here I write P7. P7. When I have this one, and you can see these are just references to this. This one is this list, this one is this list, so I don't have to check the whole list at once. It is too complicated, and then I can just concentrate on the parts which I really interested in. And of course you can see the while loop here. You have check, of course, here 1 0. A while loop has also conditions, true and false condition, and here we are not finished. So you can see this is part 1, but right now I just indicated, but this is not finished. We can write here nothing. Normally you would continue here, so the better way is just to indicate here an arrow. And like I said, when you see just an arrow, it means it is not, there is something wrong, because every arrow needs an endpoint. This is just indicating not finished. And this one here on the other side, here you can make an arrow because we know the else part. The reason why that we know is very simple. You can see the while loop here. It will continue with the code. So the while loop itself is finished. I can make here a finish symbol. Here I can't. Here I have the special cases, which I have to check here, which means here I jump here to this list. Here I jump to this list. And then if I make the other parts as well, I will jump into this other list. But I think I will not make the other parts, because I think you understand now the flowcharts, and I hope it can help you. But important is here that you understand this one. After you created this one and you try to explain it to anyone, you can just watch it and see here the important parts. Perhaps you can even highlight these comments here. For example, break not handled here. This is a very important part here. This one here, because I have not covered this one. This one is very hard to understand, break handled later, but you have to explain this. That's why we have the comments. The other parts here where I have no really big comments, in this flowchart means easy to understand. So when you read, for example, this P8, you jump just to P8. Then you read this position 8, it says here, okay, we have here P8 is a condition, and this comment is very important, right? In a flowchart, the comment, it says here, check pointer must be set at this point. Okay, that should be clear now what happens here. The comments will tell you. The other parts which I showed you, this two are not so easy or not even handled, which is a way work to do. And in the next video, I want to show you that you can even find a bug, because in my code here, which I created, there is an interesting bug. And you can see it with a flowchart, and I made, there is one more thing which I want to mention. You can, of course, simplify all the things. You can, if you say, I understood, for example, that's also very important. You can say, I understood this part already, right? You can say, this part was for you so easy to understand that you don't have to cover this at all, right? So with other words, what you can do is you can just use this one here, what I created, and just don't make the whole graph here. You just make here this as a placeholder and comment it just like, let's make it so. Let's demonstrate it. So let's make comment here, paste this here, put this here, and I write here a comment is skip, oh, not with this color, write it with this, skipping part 3. Easy to understand. And to write here perhaps easy to understand. Easy to easy to understand. Just for yeah, you can write something like that, and then you can make this one. And the reason why you can make this kind of stuff is just to skip the code. For example, there is a part which is absolute perfect, there are no errors and easy to understand, and then you can skip the part, right? Or you can say, like I said, this symbol here, which I use, means make it later. So you can also say I do it later. Something like easy to understand or make it later. Let's make it later. Later or not at all or first, right? We said we can make it first. In our case, this was our first. I made it first here. In this case, I made this offline. This one I can make later or not at all. Not at all, because you say it's just too easy to understand, so we don't need to cover this part. I can skip this part, go to the next part, and you can only represent in your flow graph the more difficult part, because the second part here, this one, there is an error. You should indicate this anyhow. But let's say you have in the part 3 no errors, or the first part was too easy actually. This one, which I showed you in my first video, that was so easy, I think you don't need even create this one here, because the first part, when we go back to the first part, he was just creating this one. There was an error as well, I think, but let's say the first part was so easy that you say, hey, this was just waste of time to create this, right? You can just still indicate it. There is a first part because you need to indicate this, and just skip the whole part and just concentrate on the parts which you don't, which you think another programmer will not understand, or which you think where you have problems, like this one, which you have to check separately. Here I have problems. And yeah, that was also very important here to mention. You can use the flowchart to skipping a lot of parts, because the flowchart, like I said, it should just help you. And you can see I try to simplify as much as possible. This one will be my final result later. Something looks like this. Here is the end of the while loop. Here's the start of the while loop. Here I have simplified it, and then I indicate the errors. Perhaps I would write here need check. For example, here this section needs a check. Need check this section, and the reason for that is I have problems here. need check, so I just can concentrate on this block here. This block I can say perhaps it's okay, that was anyway too easy to understand, that was perfect. I can skip this part, so I have just, for example, checked this part, and you can see that was not really handled very nice, and so on. All right, but my code here which I made has still a bug. Interesting. And when I talk about bug, means normally it's an error which is not detected by the compiler, but by the way, we saw in my case we have here many bugs. This kind of thing here, what I made here, are also called bugs because you handled it not right, which means can cause problems, right? Depends on the problem, it can be worse or not so worse, but important is it is a bug, more or less. Can cause problems. Cause problems means all time bad. But here is another interesting bug in my code, which is actually, in my next video I will try to show this. The bug is so that it's an error, but the code was so made that it could cover this error and it looks like all works fine. And it works indeed all fine because it was recovered in another place, which was not intentionally. That was just random luck. And that's why it's an interesting bug, which I want to show you. And I hope that you understand this flowchart here a little bit more in detail. And yeah, again, try to make this, and the goal is make it as simple as possible. Important are comments, like you can see here. If you read a flowchart like this one, you are reading more the comments, right? When you see here P11, what is that here? P11, jump there, P11, because here, when you read just the keyword again, we know the keyword is just breaking out of a while loop. Yes, we know it, but what is the meaning of this one? And it says here I made here break not handled and a red circle, which means you have to work probably here. It says here then wrong, no error message here. You can use throw, but not so good. And yeah, the comment here says no error message here. So oops, what? Okay, we have to check this one and then check this error message here anyhow. So you have to work here. Here is still work to do. It's indicating I have this one. All right, with that said, I think you should try it. And like I said, if you say this is not worth it as a starter, don't worry, just don't use it. It's good to know, but in future for more complicated source code, this can help you a lot to analyze code in a very visual way, very easy way, because you can make this very fast. But there is a warning. This flowchart has one big problem. And this big problem is that what I already indicated before, these flowcharts only show you the flow of a program, which makes it easy to understand. But the flowchart shows you not all cases of a program, all states, which means if you don't know that a program can be in a certain state, the flowchart, you will not create a flowchart. And we have to talk about states in a program more in detail, because that's the downside about a flowchart. It is not covering states. We have covering states separately. And what I mean with states, again, let me show you this one. You can see when I created here this flowchart, I started this as my start point. That was this Wikipedia bubble sort. And then I just draw here the 4 nodes, and then I tried to sort this. But the problem was there was a case where it could happen that you have only 2 nodes. What happens then? How you sort this one? And you have to handle this in a special case. You can't handle this in this case with a while loop, because here you can see I make here the pointers and then I loop through here. You don't have to loop. You have just to switch this, check this, switch this, and print this later. So there is no loop. And then this is this state here. What happens here? Here I can't even assign the second pointer here because there is not a second node. What happens if there is no node at all? And you can see this, all these cases are states which we have to find before we can draw a flowchart, and that's the problem. So again, a flowchart is nice when you know every possible cases. You can make it easy to understand. But the problem, the real problem for a programmer in my case could be to find the all states that a program can have. And we have to think about this a little bit more when we talk about states. But in the next video, I want to show you the bug. And with that said, if you have any questions, any suggestions, write in the comments, and like all time, try it yourself, try to make your life more easy. And if it works, perfect. If not, still you will learn it. Don't worry, mistakes are good in programming, because the more mistakes you make, the more you try to solve them, the better you get in the future with solving problems, and that's a very big plus. And with that said, I stop this video, bye, and see you in the next. Good luck.